Okay, so we've been talking about naming ionic compounds, and hopefully you've done some practice with that. And again, a lot of this summer learning, you're going to have to look into it, do your own work, and if you have trouble, please contact me. I certainly have no problem at all getting back to you and helping you. Um, Ionic compounds. Cation followed by an anion. The cation is 99% of the time a metal that has a positive charge or some multiple of a positive charge. And the anion, much of the time, comes from a nonmetal, which has gained electrons to become negatively charged, or from polyatomic anions, such as carbonate, sulfate, sulfite, etc. And I asked you to go ahead and memorize those because they are important. And they're really not difficult. If you sit down and just look at them a few times an evening, you should be in good shape. Well, what about other types of chemical compounds? Not all compounds that we study are going to be ionic compounds made up of cations and anions. There's a there's a whole other subset of chemical compounds, and they are called covalent compounds. And whereas ionic compounds form due to the electrostatic attraction of cations and anions, covalent compounds or molecular compounds form from elements sharing electrons. And they share electrons between each other and form bonds. And we're going to study the nature of covalent bonds in much detail as we move through the marking periods. But for right now, let's just talk about naming them because it's pretty straightforward. Matter of fact, I think covalent compounds naming covalent compounds, it's a very easy task because covalent compounds are made up of two or more nonmetals. So if you're made up of two or more nonmetals, well, then we just go to the periodic table and we hopefully, know where the nonmetals are. That's something that's up to you to learn from of the video I made on the periodic table. And if I combine two or more nonmetals, such as carbon and oxygen, well, then I can form carbon monoxide or carbon dioxide. And if I take sulfur and I form bonds with hydrogen, I can make hydrogen sulfide. So I have many, many chemical compounds that I can make from metals two or more nonmetals binding, coming together in a covalent bond. Okay, so let's take a look at some of the things we're going to need to know in order for us to make covalent compounds and name them. Well, we're going to use these prefixes for numerical quantities: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And we're going to use these because, unlike ionic compounds, where sodium chloride always forms with one sodium and one chloride, covalent compounds, you can have a multitude of different combinations. So we have to differentiate them by using these prefixes. So, for example, if I have one carbon, I might use mono in front of it. If I have two, I might use di or tri. It depends upon the chemical compound. So I think the best thing to do is just jump right in and look at some examples because there are some exceptions to rules, and I'll talk about those as we go along. Let's take a look at these binary covalent compounds. Binary, again, means just two elements. That's all I have. In this case, I have silicon and oxygen, and these are both nonmetals. And I have one silicon and two oxygens. So we would call this silicon dioxide. Silicon dioxide. And, there shouldn't be an E there. Silicon dioxide. So the second one, and you might say, why is it not monosilicon dioxide? Well, there's like a little caveat in the rules that say, hey, if my first element, if there's only one of them, we don't have to say mono. We can just say silicon dioxide, not silicone. And for the example number 2, carbon monoxide, one carbon, one oxygen. as opposed to CO2, which would be carbon dioxide. So we have carbon monoxide. CF4, carbon tetrafluoride. Tetra means 4. Okay, things get a little strange when we get to N4O4 because nitrogen and oxygen can form many different compounds. They can get together and form nitrogen monoxide, dinitrogen monoxide, nitrogen dioxide, dinitrogen tetroxide. In this case, we have tetra for 4, tetranitrogen tetroxide. There we go. Tetranitrogen tetroxide. Number 5, xenon hexafluoride. And xenon's interesting because it's a noble gas, and we don't normally think of them as being reactive, but xenon will form some interesting compounds with fluorine. So you get a chance, we'll study those a little bit later. These are very interesting compounds discovered, I believe, by a scientist named Bartlett. I'll have to go back and check that. N2O3, dinitrogen trioxide, 2 nitrogens and 3 oxides. And what do you think this last one's going to be? Well, I have 4 phosphoruses, so tetraphosphorus heptoxide. So tetraphosphorus heptoxide. And it says heptoxide, but sometimes we just kind of slur it together and say heptoxide. It sounds a little less cumbersome, and it sort of blends those two vowels together. So these are naming binary covalent compounds. And it's even easier to go from a name to writing the molecular formula. Carbon dioxide. So if the first element, if there's only one of them, that means 1 carbon, but di means 2. So carbon dioxide is CO2. Phosphorus trichloride. There's nothing in front of the phosphorus, so that means 1 P and 3 Cls. Phosphorus trichloride. Sulfur tetrafluoride. 1 sulfur, 4 fluorides. And again, we indicate that number 4, of course, by the little subscript in case you've forgotten. Disulfur dichloride. 2 sulfurs, 2 chlorides. Iodine monochloride. ICl. 1 iodine, 1 chloride. And notice once again, if I didn't make this clear through examples, the second element changes its name from oxygen to oxide, chlorine to chloride, just like in ionic compounds. So dinitrogen tetroxide, dinitrogen, so that would be N2 tetroxide O4. Nitrogen triiodide, I have 1 nitrogen and 3 iodides. So there's my name, or there's my formula for the name. There goes my dog down the hall. If you hear someone rattling, it's just little Ginger. So that's it. That's how you name covalent compounds. There's really nothing to it. If you want to go ahead and try these again, go ahead and pause the video and go through them. Make sure you come up with the names. And then, of course, you can check yourself. And you could pause the video here, try to rewrite them, and then check yourself once again. So like I said, really nothing to it, and hopefully you will be well on your way to doing this. And I'll post a little activity before